Welcome to this lecture on variables, pointers, and references. We're going to take a quick look today on different types of variables, including different types of const pointers and this sort of thing. We'll talk about parameter passing and returning values from functions and thinking about these in terms of the memory accesses that we do. In C++, we have three different types of variables. We have plain variables like an int or a char. We have references to variables, which are basically renamings of those variables. And we have pointers, which are addresses which allow us to access another memory location. Also, we can have const versions of each of these. Okay, so I want to look at different types and talk through a bit about how these all are used. So we have this plain variable int x, here's a pointer, and here's a reference. And references, of course, need initialization. We can't initialize them later. We have to say int x. This would be a useless declaration. We have to say int ampersand x equals some other variable. Okay, to say that that other variable can also be called x. We also have const versions of these things. We could have int const x. We could also have written that as const int x, and that would mean the same thing. And what this means, of course, is that x may not be changed. Okay. We can also have const pointers, and you'll see here there are actually 5 different types of const pointers, which are grouped into 3 groups. Okay, this might be new information for you, so pay attention here. Int const star or const int star, these mean the same thing, and what they both mean is that splat x or star x may not be changed. Okay. The value at that address cannot be changed, but x can be changed. So in other words, we can change where x points. X is a pointer. We can point it to any memory location. It is not const. What is const is the thing that it refers to. So wherever it's pointing, we cannot change that value. Okay. Now you might be wondering, why is int const star and const int star the same? And isn't this the more common one? It is the more common one in programming. You'll see const int star more often, or const blah star. But actually, this one is preferable, okay? And that's why I'm bringing it up. So it's preferable because when you read it backwards, it actually says what it is. X is a pointer to a constant integer, okay? It says what it is. Now, here's another type of constant pointer, int star const x. In this case, x itself may not be changed. X is a pointer and it points in one location, and that location cannot be modified. But we could follow x to that location and mess around with the data at that address. Okay, so this is kind of the opposite type of const from what we just looked at. And again, you'll notice that if you look at this, int const star versus int star const, here we see x is a const pointer to an int. Okay, so we read it backwards, we can see what it is. And furthermore, we have sort of this double const behavior here, int const star const x or const int star const x, which mean the same thing. And again, you might more often see the second one, but the first one is preferable because if we read it backwards, we get x is a const pointer to a constant integer. And of course, this means that neither x nor splat x may be changed. We can't move where x points, and we can't follow x. We can't change the value at the address where x is pointing. Okay. Finally, we have constant references. And if it's a constant reference, then that just means that since x is just a name for something, a reference is just a name for something, we can't change the value at that name. Okay, so this is sort of like a const plain variable. Now, in this class, I want to bring up this convention that we're going to use for passing parameters into functions. In this class, we'll usually pass parameters by one of 3 ways: value, which is also known as copy, const reference, or pointer. And we're going to use those 3. We'll use others on occasion where we're forced to, but wherever possible, we'll use only these 3. And we'll use pass by value if the parameter is small and may not be changed by the function. We use pass pass by const reference if the parameter is a large object and may not be changed. So what's the difference between small and large? Well, an int is small, and usually an object is large, okay? And we'll pass by pointer if the parameter may be changed, okay? Notice that what you don't see in here is you don't see pass by reference. Now, on occasion, we will use pass by reference because of some standard ways of doing things like with output streams and input streams with C++. But we will, wherever possible, only use pass by value or copy, const reference, or pointer. Now, of course, we call it value or copy because when we pass in an integer by value or by copy, the function that's receiving it gets its own copy, right? So the function can change that, but it doesn't change the value that was passed in. Passing by const reference doesn't make a copy of the thing that was passed in, but because it's const, that thing cannot be changed by the function that's being called. And passing by pointer makes it clear that we are passing something that the function itself might change. It's perhaps clearer if I illustrate this with an example. So consider these four functions, f1 through f4, with pass by value, pass by non-const reference, pass by const reference, and pass by pointer. Okay, so we have four different types of parameters that we could pass here. And imagine if we passed, if we had calls to these functions as follows. We call f1 with a, and what happens when we call f1 with a? Well, f1 gets its own copy, which it calls x, and f1 cannot change this a because this x is a copy of that a because it's passed by value. Okay, f2, we pass by reference, which in f2 is called x. f2 could come in here and change x, which would also change a. Okay, and I'll talk about why that's bad in a second. f3, we pass by const reference, and that's okay, because even though we call it x here, because it's const, f3 cannot change what a is. So even though x is referring to a, f3 has promised through this signature that it will not change a. And finally, we have pass by pointer, right? And f4 can change a, but we're passing the address of a. Now, the reason behind using value, const reference, and pointer, but not reference, not this one, is because look at these three. In these three, we're passing a, and a. And in two of them, a is safe from changing. F1 and F3, a is not going to change by the functions that are being called. But in this one, pass by reference, notice it could be changed, but we can't see that difference. In F4, we see the difference. We pass by pointer, we're required to take that address right there, which warns us, hey, beware, a might be changed by this function. So again, this is not magic, but it's just a convention that we'll use in this class to tell us if something's going to change, let's pass it by pointer so that it's clear that it might be changed to the caller. Let's not use pass by reference because, or as much as possible, because that might lead us astray by making us think, well, this looks like a call by const reference. It also looks like a call by value. I don't know what it is, when in fact it could change that value. Okay, let's talk about returning values from functions. We can also return in similar ways by value, which is copy, or reference, or pointer, or const versions of all of these. And as I talked about extensively in the past, never return a pointer or a reference to a local variable. And we'll test our understanding of that on the next set of slides. Remember that local variables reside on the runtime stack, and when a function returns, they are automatically deleted when the function returns. So that's not a valid reference anymore. Now it might work. It might work on sporadically, but you get some pretty crazy bugs if you rely on something that's not dedicated being still available. Okay. Now, this is a quiz, which I'm not going to go through in detail in this lecture, but what I want you to do is pause this video, copy down this information, or if you have the slides, get a copy from the slides. And what I want you to do is test your knowledge of memory, of return types, of the longevity of memory, and of what's valid to return and not return. And what I want you to do is think about these four functions, okay? All of these four functions compile, and they all run. And I want you to think about them being called in this manner, and then just determine for yourself, of these four, some of them are quote unquote okay, as in they have good behaviors, and some of them are not okay, as in they do bad things. And I want you to determine which is which and why. Okay. So again, we won't go through this in detail right now, but we'll go through it in an interactive session. So copy this down and try to determine for yourself which is okay and which is not. Okay, so in summary, what I want you to get out of this lecture is to understand the difference between values, plain variables, references to those, and pointers to those, and these const versions. And know when you should use pass by value versus pass by const reference versus pass by pointer. And that in this class, at least, we're avoiding pass by reference, though we will use it on occasion. And of course, never ever return a reference or a pointer to memory that lives on the stack, because that's going to go away as soon as the function returns.